Okay, so we are talking about the language accepted by the PDA. Just to recap, so given a PDA, what do we mean by the language accepted by the PDA? So, suppose we have given this PDA, this is the set of states, this is the input alphabet, this is our output stack symbol, all are finite. This is the transition rule Q0, Z0, A. So, Z0 is the current position of the stack. Now, we have two types of acceptance by this PDA. One is the language accepted by the PDA by means of final state. So, that means, if this is the set of all strings for which the current, this is the current idea of this situation. So, we start with W. So, Q0 is the starting state and W is the current position of the tape. So, this is W. W could be say A1, A2 like this, and Q0 is the current which is pointing here, and the stack symbol is Z0. Okay. If it is, I mean Z0, this is the current ID of this, and if it is reaching to the sum of the ID, we apply the delta rule on this. So, it will change, it will go to the next input and it will change this thing. So, if eventually it is going to some p, and if input alphabet is over, if we read all the input, and we do not care about this output alphabet, where p is some for some state p from the final state. Okay. So, eventually if it is going to, so tape is over, there is no more, nothing is there in the tape, and we are going to p, and we do not care about this thing, because this is accepted by the final state, and if this is the final state, then we say this string is accepted. So, collection of such string, we tell this is the language of this PDA by the means of final state. And similarly, we have language accepted by the PDA by means of empty stack. This is denoted by n of this is set of all W, such that we start with Q0, we take this Z0, if it is going to, we do not care about this state, it could be anything Q, epsilon, epsilon, for any state, for any Q belongs to Q, need not be a final state. We do not care, I mean could be a final state, but we do not need that. We only need the ultimately stack symbol should be empty. So, this is the current position of the input tape A1, A2, AN, and this is Q0, and our tape header is this, and this is Z0 stack, and ultimately the input will be gone, and we are at Q, and stack is nothing, empty, epsilon. So, then that is called n of this. So, we will see how they are equivalent. I mean, given a, they are basically the same. I mean, given a PDA which is accepting by, which is accepting a language by the empty stack, then we can construct easily a corresponding PDA which will accept by the acceptance state. So, we will see that. So, before that we will take some example where we will see it is accepting by the empty stack. Some of the string we will see those are accepting by the empty stack. So, we will take some example. So, let us take some example. So, we want to construct a PDA that accept this WWR. So, palindrome basically. So, here W is in 0 1 star. So, that means W is 0 plus 1 star. So, we would like to construct a PDA which is going to accept this language, I mean in terms of the empty stack. Okay. So, the idea is, so we take just two states, because here states are not important if we are talk about the accepted by the empty stack, and say this is our input alphabet and the stack symbol are 3 R, B, G. We'll see, and this is our transition rule, and our Q1 is the starting state and R is the that Z0, that is the starting symbol in the stack, and we have no final state, because we are talking about this in terms of accepted by the empty stack. So, we do not care about the final state. Okay. The idea is, if we see a 0, then we will push B into the stack, and if we see a 1, we will push G into the stack, okay. And then we will be at state Q1. I mean, if we see these are, we have to remain at state Q1, and if we see a 0 and if we see a B in the stack, we will erase the B. I mean, we will go to, we will replace this by epsilon. We will see the rule, erase B, and we will change the state, and 1 G will erase G, and epsilon R will erase R, and our state will be Q2. Okay. So, this is the rule we will follow. So, if you follow this rule, we can write the delta. So, delta is like this. So, delta of Q1 0 R, sorry, R is the 0 comma R, R is the starting state, I mean that is corresponding to that our Z0. So, then this is going to singleton set Q1 will be remain at Q1 and will push B, that is the idea, B, R will be remain same. Okay. Delta of Q1, if you see a 1 R, if you see a 1 from Q1 we will push. So, we will be remain at Q1, that is the rule we are following, and we will push G, GR. So, this is again a singleton set, and then delta of this is non-deterministic, but we have only one option over here, that is fine. So, delta of Q1 0 B, if we see a B 0 B, then we have option like this. Here we have two options, we can go to Q1, then 0 B means we will 0 if we see we push B, that is the push B one option, or we will go to Q2 with epsilon. We will just erase this B. So, this is another option, and delta of Q1 0 R 0 Z will be, this is also singleton set Q1 B G. Let me write this, then it will be more clear. Delta of Q1 0 B, the delta of Q1 1 B, this will be Q1 1 B, this will be Q1 G B. Okay. And delta of Q1 1 G. So, this is rule 1, rule 2, rule 3, rule 4, rule 5. We can write this R 1, R 2, R 3, R 4, R 5, R 6. So, R 6 is basically delta of q and. So, here we have two options like this. So, q 1 g g or q 2 epsilon. This is non-deterministic. So, we can have more than one option. R 7 is nothing but delta of q 2 0 b, q 2 0 b, it will be q 2 then epsilon, it will be q 2 epsilon. I write it here. Okay, so, this is R 7, R 8 I will write here. R 8 is delta of q 2 1 g, this will be q 2 epsilon, q 2 epsilon, and R 9 and R 10 delta of q 1 epsilon, we have epsilon move also, this is q 2 epsilon, and the last one is delta of q 2 epsilon r, this is nothing but q 2 epsilon. Okay. So, this is the transition rules, and we are so this is the transition rules of a PDA. So, there are these are our this is our deltas. So, now if you draw this, we can draw this. So, we have a q 1 2 state, q 1 q 2. Okay. Now, from q 1 if we see a 0, so let us write this move. So, from q 1 if we see a 0 and if the stack is r, it is going to q 1 and the stack will be b r. So, that we can write like this. So, q 1 if we see a 0 and if the stack is the top of the stack is r, then it is going to same state q 1 and the stack symbol will be replace r by b r. So, that is the way we usually like this. So, similarly, we can write 1, if we see a 1 and if we see a r over here, then it will replace to the stack, it will be remain at q 1. So, will be remain at q 1 and the stack symbol will be g r like this. So, let me complete this 0, if we see a b, it will be b b, and if we see a 0 g, then it will be b g, with the same state it will be remain, and 1 b it will go to 1 b. So, if we are q 1, if we see a 1, if the stack is b, it will go to remain at q 1, but the stack will be g b. It will go to g b. Okay. And with 1, if we see a g, it will go to with 1, if we see a g, it will go to g g, or it will go to, with 1 it will go to, there is one option here, with 1 if we see a g, we go to q 2 and this one we are writing, we go to q 2 and g will be erased, like it will be epsilon. So, if we have g, it will be epsilon over here. Okay. So, this is just we are trying to draw this. Okay. So, now with Q1 with Q2. So, with Q1 we have another move over here with 0, and if we see a B, it will go to Q2 with epsilon, and if we see epsilon r, it will go to Q2 with epsilon. So, this one Q1 epsilon r, it will go to Q2 with epsilon. Now, here also we have the self loop. So, like this. So, if we see a 0 and B, it will go to epsilon, and if we see a 1 G, it will go to epsilon. Similarly, if we see epsilon, it will go to R. If we see R epsilon, like this. So, this is the transition diagram of the PDA, corresponding PDA. Now, we want to see what type of language it is accepting. We want to see the string, what type of string it is accepting. We want this to be, this should be parallelogram like WWR, R is the reverse of that. So, let us check whether where it is going. So, we can use that. We can use the diagram for this transition ID, I mean description. So, okay. So, now we want to see, we want to read a string like this. So, 0 0 1 1 0 0, this is a parallelogram. Okay. Now, what is the this we want to read? We put this in a tape, and what is the current state of the, we are at Q1, we put this in a tape like this 0 0 1 1 0 0. So, we start with this, and what is the initial state? Initial stack symbol is R. So, we are going to read this, and we change the ID. This is the snapshot of the initial state of the initial photo of the initial snapshot of the PDA, and depending on the transition we will move, we will go to some other ID, we will go to some other ID like this. So, eventually if we can using this, eventually from Q1 WR, we want to see whether we can reach to this situation, like we do not care about the states, any state Q is either Q1 or Q2, and this should be epsilon, this should be epsilon. So, you want to see whether is there any path which can reach us to this situation by the move relation. Move relation means ID relation. I mean, we have the current instantaneous description, then it is going to the next instantaneous description and like this. So, by the using the transition rule. So, we will see that. Okay. So, let us try to draw that. So, initially we are at this is the initial ID Q1, this is the W 0 0 1 1 0 0, and initially our stack is R. So, where it is going? It is going to, so we are reading this. So, delta of this is now transition is Q1 0 R. So, Q1 0 R. So, we are at Q1, we are reading 0, we are reading R. So, it will go to Q1 0 R. Yeah. So, we will take this rule Q1 0 R means, so we will take this, we are reading this symbol, we can read epsilon also. If you read epsilon, then it will be like delta of Q1 epsilon R. So, if you read epsilon, so Q1 epsilon R is nothing but where it is going Q1 epsilon, if we so delta of Q1 epsilon R, it is going to, so it is giving us what? It is giving us Q2, it is going and R is gone. So, it is going to this Q2, and this will be remain same, because we did not explore any string other than epsilon. We are just only took the epsilon and then this will be empty. Once this stack symbol is empty, we cannot move further. So, halt, this is a halting situation, halt. So, this branch cannot proceed further, because once the stack symbol is empty, because for delta transition we need to have the stack symbol to be stack should have some symbol on the top. So, this situation is halt. Now, we have to proceed this way. So, we can read this. So, if you read this, we have to take the delta of q 1. This time we are not taking epsilon, we are taking a valid input symbol which is 0 and r. So, this is what? This is nothing but q 1 0 r is nothing but q 1 and r is replaced by b r. So, this is going to q 1. So, this is gone. So, 0 1 1 0 0 and r is replaced by b r. Okay. So, similarly, we can try with now we can read 0. If we read 0, we are not considering epsilon move, because epsilon move will be getting halt in some situation. But anyway, I mean, if you want to have a complete tree, you should explore with the epsilon also. Okay. So, now we are in a situation of delta of. So, we want to read 0, q 1 0 again, and now our tape header is b. So, q 1 0 b. So, q 1 0 b, q 1 0 b has two options. One is q 1, we are at q 1, if we see a b, it can go to b b. So, like this it will be remain at q 1 and 0 we have already read, and b is going to b b. BBR. Okay. And another option is this one. So, q 1 0 b, it will b will be removed. So, this will be go to q 2 and 1 1 0 0, b is going to epsilon. So, this will be erased, we have r. Okay. So, then q 2 then from here we can proceed, but we will see it will be halt after some state. So, even it will halt with the next symbol. So, anyway, we will try to proceed with this. So, now we will say this and b. So, 1 q 1 1 b. So, q 1 1 b. So, we are at q 1, we see a 1 b, 1 b, it will go to g b and it will be remain at q 1. So, q 1 1 0 0, b will be going to g b, this b. So, b r will be remain same. This is the stack, this is the top of the, we are always reading the top of the stack. So, like this and 1 0 0, we can now go to, we can read this one with g. So, we are at q 1 with 1 g. So, q 1 1 g. So, q 1 1 g have two options, q 1 1 g can be epsilon also. So, this is going to q 1 again 0 0. So, g will be replaced by g g, g g b b r. This is one option. Another option is here, if we take this one q 1 1 g. So, this will be q 2 and this is 0 0 and this g will be erased. So, BBR. Okay. Now, we could explore this also, but let us try to explore this one. So, this will go to where? This will go to now q 2 we will see a 0. So, q 2 if we see a 0, it will be with b. So, it will be q 2 and 0, b is erased, b I. Then again this is the instantaneous description. So, this I should use this notation. Then okay, then this one again we see a 0. Now, with b it can again go to q 2, then 0 is gone, epsilon is here, B is will be erased by epsilon. So, this is R. Now, Q 2 0, Q 2 epsilon R. So, if we see epsilon and R, if you see epsilon and R, it will be Q 2 and R will be sorry, this is epsilon, this is not G. So, if we see epsilon and R, then it will be Q 2 epsilon epsilon. Good. So, this branch is going to empty stack. Even with this, if you work little more step also here, it is going to empty stack. So, finally, from the starting initial ID, we could able to reach to the this ID, I mean which is having the situation where empty string is empty and the stack is also empty. Okay. And remember, stack will hold if the stack is empty. So, now it is holding and it is reaching to the we have already explored the we have already exhausted the input alphabets. So, that means, this is going to So, this is the initial ID, is Q 1, then this W is 0 0 1 1 0 0 R. This is going to this is going to the ID like this, Q 2 epsilon epsilon. So, this implies 0 0 1 1 0 0 belongs to n of this. This is belongs to not epsilon. So, this belongs to n of this. So, this string is accepted by the PDA in the sense of empty stack. Okay. So, we can prove the all type of WWR will be accepted by this PDA in the sense of empty stack. So, in the next class we will see the this equivalency between the this empty stack and the language accepted by empty stack and the language accepted by the final state, and we will see the these are basically the class of context free language. Thank you.